Okay, here's the first pointer example. This is just called pointer.c in the Chapter 13 folder. It's pretty straightforward. It just uses that pair of variables that we were looking at in the slides. But now I want to actually go and look at some of the syntax. Here we have 4 lines of code. The question is, which one of these four, is a legal and meaningful first step that this program could carry out? What do I mean by legal and meaningful? Well, firstly, that it will compile, and secondly, that it will actually do something that won't crash the program, or is actually useful, or valid, or whatever you want to call it. I'll give you a hint. 2 of them are legal, in other words, they will compile, and 2 of them will not compile. Of the 2 that will compile, only 1 of them is legal and meaningful. Now, I'm going to go through this slowly by explaining what each one of these lines does. I'm going to put a little comment next to it. And those comments will be saved in this file pointer.c, so when you go and look at it, it will have comments in it. And I'll explain each one as we go. Okay, let's have a look at the first one. What's going on here? This says star PTR equals X. So let's try and translate that into English. The contents, or the thing that PTR points to, the value that the thing that PTR points to is set to X. Is that legal? Well, X is an integer. Good, so it is legal. That will compile. So I'll now put a comment next to that. So it's legal, but is it meaningful? Is it useful to do that as a first step in this program? And the answer is no. It isn't. Why not? Well, because I actually did discuss this in the slides. PTR has not yet been initialized. The pointer variable itself is just pointing off to some random area of memory. You have no idea where it's pointing to at the moment. So what you're doing here is you're effectively taking the value of X, whatever that happens to be, and that's not initialized either, but that's not quite so crucial. You're taking whatever integer value is in X and you're assigning it into some random area of memory. In other words, you're overwriting some piece of memory that you have no idea which piece of memory it is, and you're overwriting it with some random number. So that is not a good first step for this program. I'll just put that into the comment as well. So it's legal, but it's unwise because PTR is not initialized. Neither is X, but that's not quite so crucial. Let's look at the next line of code. Address of PTR equals X. Now, will that compile? What does that mean? It means take the address of the pointer. Take the address of the pointer. You can take addresses of pointers. They are variables, and every variable has an address. If you recall back to our slide, X had the address of 103, and PTR obviously had the address of, I think it was 111. So pointers have addresses as well. So it's actually possible to have a pointer to a pointer, but we'll look at that in a later chapter. I know that sounds scary, but it is perfectly okay. Anyway, the address of pointer, let's think back to our example, that would have been 111, and we're trying to set that to X. Now, the address of the pointer is the address of the pointer. We can't change it. We can't move pointer from one place to another, which is what it looks like we're trying to do here. If PTR is 111, so if the address of PTR is 111, that's cast in stone. PTR lives there, and that's where it lives. We cannot ask it to live somewhere else. So that is not legal. The compiler will reject that. So I'll put that in there. Okay, so we're actually, it seems like we're attempting to move PTR around from one place to another, and you simply can't do that. It's not a valid thing to do in C. Okay, let's look at the third example. PTR equals address of X. So it means take the address of X and assign that to the variable called pointer. Now the address of X is, well, from the example before, it was, what, 103, and PTR is a variable that can contain an address, so it looks pretty legal. It is legal. I'll put that in now. The next question is it meaningful? Is it okay to do this as a first step in a program? And yes, it is. It's an initialization. It's setting pointer to be equal to something. It's initializing pointer. It's saying, okay, I've got a pointer here that doesn't point to anything at the moment. Set it to point to X. It doesn't matter that X is not initialized yet. We can initialize X next, or we could have already initialized X. It doesn't really matter. All we're doing here is initializing pointer. We're setting that big yellow arrow to point to 103, the memory address 103. So I'll just write that into the comment as well. Okay, so it's legal and meaningful, we're initializing pointer. So obviously the final one is not legal and it's not meaningful. Why not? Well, we're almost like we're pretending that x is a pointer and we're trying to find the thing that x points to. But x is not a pointer. X is just a plain old integer. So x cannot possibly point to something. So taking the contents of x is a meaningless thing to do. So I'll just write that into the comment as well. Okay, so x is not a pointer, it can't point to anything. Okay, that's all I wanted to show you in this particular example. I've got another file prepared called pointer2.c. Let's have a look at that. Here we are, pointer2.c. This one we actually are we're trying to achieve something. We've got a float called f, and we've got a pointer to a float called ptr. What's our task? Our task is to get the value of 3.5 into f. That's our task. Well, that sounds easy enough. Let's do that. F equals 3.5. Simple. Okay, we also want to do it without using a statement that begins f equals. Notice this statement does, of course, begin f equals. Okay, so we obviously can't do that. What can we do? Let's get rid of all these question marks. Well, we can, if you like, assign a pointer to point to f, and then by using the pointer itself, we can say the thing that the pointer points to, set that to 3.5. Now that will effectively set f to 3.5, but we'll be doing it via the pointer. So that's a two-step process. First of all, we need to set pointer to point to f. You remember how that's done? Okay, so we need to set pointer to equal what? Well, we need it to point to f, so it needs to be set to be the address of f. Okay, so that's simple pointer initialization. Next, we need to say that the thing that pointer points to, set that to 3.5. So the thing that pointer points to is written asterisk ptr. We set that to 3.5. Okay, now, will it compile and will it work? Those are the questions. Let's try and find out. Compile. Yes. So it does compile. Does it run? The value of f is 3.50000. So that's working. Notice that we are finding out the value of f here. We could just as easily change that to star ptr. In other words, this printf could be just as useful at telling us what is the value that pointer points to. Let's try that. No errors. And again, it's 3.5. So I'll just put that back the way it was. So it can work either way. Okay, I hope that's clear. Now I'm going to move on to a file called pointer3.c, which is a different set of ideas again. This is pointer3.c. Now I want to do something a little bit clever here. I've got two variables, x and y, and a ptr pointer that points to a character. It doesn't point to an integer, it points to a character. This program's in two parts. The first part is to find out the current memory address of x and y. And you don't need to use ptr to do this. ptr is only used in the second part of this program. Okay, so let's go and have a look at this printf. We need to find out the memory address of x. And what's the memory address of x? Well, it's going to look like this. It's going to be ampersand x. That's the address of x, correct? Okay, but now we need to actually display that. So we need to put a percent something here. Percent what? Percent what? Okay, now we can look at the hint. Memory addresses are 32-bit values, and so are integers. Well, they probably are. I know that they are on this computer. They may not be on your computer if you're using a 16-bit operating system like Windows 3.1 or DOS. So if you're using one of those, then their memory addresses are going to be 16-bit values, but then so will integers. So it's interesting to note that memory addresses are always the same size as integers. So if a memory address is the same size as an integer, surely you can treat this number here, this address of x, as an integer. the address of x can be treated as an integer. X is an integer, but the address of x is also an integer. Recall back to our diagram. In fact, I'll go back there right now. Okay, here we are back at the diagram. X is an integer. 5, yes, x contains 5, but the address of x is 103. Now, notice that that is also an integer, so it's quite possible to print out that value as well. So that we could do two things. We could print out the value of x, which is 5, or we could print out the address of x, which is 103. Well, in this trivial example, it's 103. Let's see what it is in the code. Theoretically, we can just do this, %d, and you can treat that whole memory address, which might be 103, as an integer, and print it out. And then we can do y again, %d, it'll be exactly the same. The address of y. Okay, let's see if that compiles and runs. Okay, so it's actually okay to do that. That's a clever little bonus of printf that you can do that. Let's run it. Okay, so now we're actually having a look at, for the first time, at some real live memory addresses. The address of x is 39058900, or 39,058,900, and y is 39,058,896. So y is positioned just before x in memory. Just before. It's 4 bytes before. It's 4 bytes difference. Now, if you think about it, y and x are both integers, which means they take up 4 bytes of memory. So y is taking up 4 bytes of memory from 896 to 900, and x is taking up the next 4 bytes of memory from 900 to 904. Does that sound cool? So that's what's going on. Okay, let's go and look at the second part of our program. Here's the second part. PTR is currently uninitialized. This is PTR up here. It points to a character. It's currently pointing to some random area of memory. Would you agree with that? It's pointing to some random address. It contains some random number which is interpreted as an address, so you can think of it as pointing to some random area of memory. Now, because PTR is a character pointer, it's a pointer to a character, the thing that it's pointing to, well, the value at the address that it's pointing to must be a character. Well, can be interpreted as a character. So let's find out what that character is. Okay, let's see if we can do this. The current random address that pointer is currently set to is, well, we can do that just like we did before. Just like this example. This is an address. It's a real address. It's the address of x. And so we can put PTR there as well and check out PTR's address. I won't fill in the second half yet. I'll just see if this is working. So compile, no errors, and run. Now we haven't filled in the second one yet, so that's just question marks. The current random address in pointer is, so this is an address now, 201,328,000, no, it's not even that big, it's 2,013,281,329. So that is, certainly looks to me like a pretty random address that pointer is set to. Okay. So that is an address in memory. That address can be interpreted as a character, as a single character. I wonder what that character is. Let's have a look. Well, a character, if you do a printf of a character, it's %c. And now we just simply want to find the thing that PTR points to, which is star PTR. Can you see that? This bit of code says the thing that PTR points to, or the contents of the thing that PTR points to, the contents of the memory address that PTR is pointing to, that great big long random memory address, we can treat that as containing a character. Which character? Well, star PTR will give that to us, and then we simply print that out using printf and %c. So let's try that. No errors, and run. It's the letter Y. Okay, well, we happen to be pointing to something that is the letter Y, and that's just random. If you run that on your computer, you probably get a completely different answer. In fact, you could conceivably crash the program. If pointer happened to be set to zero, if the random number sitting in PTR was 0, in other words, PTR is pointing to the 0 address, the beginning of memory, then referencing through it here might crash your program. So if you're going to try this, and I suggest that you do, don't run this line of code. In other words, like comment this line of code out first, and I'll comment it out for you. Comment that line of code out first, and when you run the program, check that the answer that you get here is not 0. If it is 0, then when you run this line of code, you'll crash your program, almost certainly. If it's not 0, then you can probably get away with running this line of code. Okay, that is our introduction to basic pointers. I'm now going to go, in the next module, we're going to look at the uses of pointers. All the examples I've given you so far are very rudimentary. They help you understand pointers, but they don't really give you a use for them. So the next 2 modules, in fact, I'm going to show you the 2 uses for pointers that I described earlier in this module. In other words, to do with allowing functions to modify their parameters and making the passing of structures around more efficient. I'm going to show you examples of both of those.